Hello everyone, I am P. Gokul of CACEA. In this video, we are going to discuss a practical question solved through C program. The question is determination of rigidity modulus using torsional pendulum. Yes, let's get into the code. First of all, we need to declare the required variables for our program. First, I declared int n, which is used to store the total number of readings that I am going to proceed with. And I have been stored some other variables also in float, which are also required for our program, and some arrays and some integers I have been declared. Yes, next we are going to initialize a for loop to get multiple inputs from the user. We are going to take 3 readings, so that I have initialized a for loop to get multiple inputs from the user. First, I have been asked to enter the length of the suspended wire, and next we are going to call it the time for trial 1, and next we are going to enter the time for trial 2, and we are going to store in the respective variables. And next I am going to call it the mean for trial 1 and trial 2, and I am going to print the mean. And next time period for 5 oscillations, so that I am going to divide mean by 5, and I'm going to print the time period. And next I'm going to call it the square of the time period, which is required for our output, so that I have been called the time square of the time period, and I have also printed the square of the time period. And finally our required output is L by T square. I have been calculated L by T square. T square have been founded here, and L, the length of the mean of the length, I have been calculated, and I have been printed it as L by T square. I have been displayed the L by T square. So the loop is going to run 3 times to get 3 different readings from the user, and the mean is calculated for L by T square. The 3 readings, the mean of the 3 readings of L by T square have been calculated, and I have been printed it. This is the input from the user that is required for first half of the program. Next I am going to proceed with little program required for our final output. I am going to declare float, mass, radius, and some other variables also for our program. This R is equal to 0.000915 is the default value of the radius of the given wire. It may be vary according to the wire. I have been declared as a default value as a 0.00915 for the program. And next I am going to ask the user to enter the mean radius of the wire, and enter the mass of the disk, and enter the radius of the disk. I am going to store in particular variables, and the final output is going to be calculate the moment of inertia. The formula for moment of inertia is mr square by 2, so that I have been calculated m r and r mr square, and next line is mr square by 2. And I have to print the rigidity, the moment of inertia. And next I am going to calculate the rigidity modulus of the given wire. The rigidity modulus of the given wire, the formula for rigidity modulus is eta is equal to 8 pi L by r power 4 into L by T square. I have been calculating L by T square, so that I have been calculating 8 into 3.14 into moment of inertia into length, and next r power 4, and finally I am going to store in rigidity or by rigidity. Next I am going to print the calculated rigidity. These are the 2 output of the program, that is moment of inertia and the rigidity modulus, so that I have been printed as a result, and moment of inertia and the rigidity modulus. This is the code required for the running for program. And now I am going to run our program and going to see what's the output answer. Yes, now the program is running, and it's asked how many total number of readings. I'm going to proceed with 3 readings, so I have been entered 3. And next we are going to calculate the time for 5 oscillations. So first reading is the length of suspended wire. I have been keeping the length of the wire as 30 centimeter, and enter the time for trial 1. I am going to enter 14 seconds. I am going to go for another trial, that's trial 2, this 14 seconds. Yes, the output is mean. We are going to call mean for trial 1 and trial 2, that's 14, and time period for 5 oscillation, mean divided by 5, and finally the square of time period t square is 7.84, and L by t square is calculated as 3.83. This is the reading for first procedure. And the next, enter the length of the suspended wire for we are going to adjust the wire length, so that I have been made the length of wire into 25 centimeter, and I am going to oscillate it. I'm going to enter the time for trial 1, that's 12 seconds, and for another trial it's 13 seconds. The output is mean is calculated, and time period is calculated, and square of time period is calculated, and L by t square is also being calculated. And I am going to proceed with another reading. And so far I am going to adjust the length of the wire. I'm going to make it little maximum, that is 34.5, and I am going to enter the time for trial 1, 14 seconds, and another for trial 2 it's also been 14 seconds. The mean is being calculated, time is being calculated, and t square and L by t square, and this line indicates the mean of the total L by t square for 3 readings, for length for 30 centimeter wire, 25 centimeter wire, and 34.5 centimeter wire. The mean is calculated for L by t square, that is 4.08 into 10 power minus 2 meter per second square. This is a mean length of L by t square. Next we are going to proceed with the final output for the moment of inertia and the rigidity modulus. The mean radius of the wire is a default value of the given wire. We are calculated using a screw gauge. And now we are going to enter the mass of the disc, 1.107 kg, and the radius of the disc is being 0.06 meter. And after this we are going to get the output for moment of inertia and the rigidity modulus. Now you can see it. From this I have been entered the input. Next, the moment of inertia has been calculated using the given code, and the rigidity modulus of the given wire has also been calculated, and the unit is Newton meter. And finally I have been displayed the result as moment of inertia is equal to 0.0019926 kilogram meter square, and rigidity modulus has been also displayed, and the unit is Newton meter square. Yes, that's it. This is the final output of the program, and thank you so much. The assignment is done by Gokul.